this slide. Financial impact and social costs of carbon emissions has been a source of spirited debate. Now, what is meant by that? Well, what's the relationship between carbon and global climate change? What's the environmental damage that happens because of carbon emissions? I will let, you know, it sounds like there's going to be like a fist fight anyway in the hall. So if you want to take sides with the carbon market, that's perfectly fine. But what I have done as a researcher is I've looked into dozens and dozens and dozens of well-done scientific studies by bioscientists and economists alike collaborating to find what the social cost of carbon is. And the best estimate that I've come up with that seems to be the most solid research was derived from the 2010 Interagency Work Group on the Social Cost of Carbon, so the SCC. It's based on regulatory risk. So in other words, what's the damage that would happen to companies if we had from carbon, basically, for being regulated for carbon emissions. And it puts it roughly, the midline point is $22.12 adjusted for inflation. So this is in 2010 values. Median price per ton of carbon, the price that it should be is $22.12. So in other words, if you emit 1 metric ton of carbon, you're causing $22 worth of damage. Right now, is there a market? Not a good one. There's a market in the U.S., the Chicago Climate Exchange. Is anybody familiar with that market a little bit? Okay, a few people, a couple people. And so, in other words, there are groups that come together that want to pay others to stop emitting carbon. It's a nice idea. But do you guys have a sense for what it's trading at these days right now? $3? Actually, the last I looked, it was 10 cents. Now, in 2008, it was $7, $8. And so then it's taken a nosedive. A year and a half ago, there was legislation proposed before Congress to create a carbon market. Now, my understanding is that's been tabled. So what I'm trying to say is that when will it become economically viable to conduct biofuels? Well, okay, if this carbon market happens, though that's a revenue source potentially. But again, it comes down to is low cost of production. And so, you know, these estimates that have been done for carbon, I've done these estimates for nitrogen oxide and sulfur dioxide as well. Now let me move to my last point. I snagged these slides with permission from a good colleague, a friend of mine from the Colorado Governor's Energy Office, Mr. Matt Futch, who's the Utilities Program Manager. And so this is my fourth point, which is, it's in terms of financial incentives, do not hold your breath for subsidies. We must organize this market ourselves the way that I think most good markets form, which is, you know, can we produce at a low enough cost and replace our other fuels? I bring this up because the Colorado Governor's Energy Office has set carbon targets to reduce carbon by 20% of 2005 levels, I believe, by year 2020. And so with that legislation's in place, and so that will help in our state move the market along for carbon reduction. This slide shows, you know, Colorado carbon dioxide levels, you know, and the sources. So fossil fuel industry's 12%, agriculture's 9%. So transport is almost 25%. And so this kind of gives an indication of where those carbon reductions would take place. And so the path to the 2020 goal, you know, by 2020, we've got the reduction. This is where Colorado is heading right now. We're trying to close the gap. Okay. If you have an interest in my Colorado energy cost study, you're welcome. I'll just kind of keep that up there. You're welcome to go to my webpage. I have a pricing tool up there, and I'm happy to show you the pricing tool that looks at the total cost of energy in general. But I want to emphasize, I believe that it comes down to keeping low costs of production, and that the consortium together is working on quantifying what those costs are. But I would urge you, if this is something that you are seriously pursuing or interested in pursuing, keep in touch with us so that we can ensure that that we can convey price information to everybody and make sure that the market is able to form. So I'll take questions now. Questions? No questions? Yes, sir.
That graph you had up there, the social costs of the different technologies.
Yes.
You have coal on there, and coal is not the highest price, but yet it's the largest carbon producer.
And so,
what are some of the other attributes that are included in social costs? So,
great question. So you're right. Carbon is, it's not the biggest carbon producer. A lot of the environmental costs that come from this are sulfur dioxide and nitrogen oxide. And those have the highest health impacts. The environmental impacts, like let's say deposition in Rocky Mountain National Park, are not reflected in the environmental costs. But in terms of the health impacts, the sulfur dioxide and the nitrogen oxide are the big ones. I-25 and the trap along the Front Range causes a real, it just kind of causes this awful trap of potential health problems, not potential, actual health problems, because of the particulate matter and sulfur dioxide and nitrogen oxide. Not as big of a problem on the western slope, and it's a topographical issue. Yes?
Does private cost, how does it take into account current rebates from energy companies or from the government? Or does it? I mean, is this actual cost, or is this cost after rebates and incentives and grants?
Great question. It's cost not including rebates, incentives, and grants. Yeah, great question. Yes, Adria.
Do renewable energy credits come into this at all?
Not in this model, no. So that's a great question, and that's sort of why I'm urging, I understand, I came from, how do I say this? I came from an ag background. My dad manages grain elevators, and there are more ag economists in my family than I'd care to have. But so I understand trying to be profitable. And I understand when you're at a farm production level, you're also going to look at your incentives. But taking a step back as an economist, trying to see how a regional economy can evolve, you can't bet the farm on the financial incentives. And it's important, I believe, to cultivate an industry that is low-cost producing. So it's a great question, but no, the financial incentives are not counted in the private costs. Yes?
I want to make sure the point you're making about the carbon cost. So is it actually English tons you're referring to, or metric?
Metric tons.
2212 per metric ton.
2212 per metric ton. And that can be converted over to reflect English tons too. Yeah, that's per metric ton. Yes?
On the, I guess the y-axis there, that's
Yes.
the total cost per, what unit are you looking at?
That's per megawatt hour of energy produced. And so included in that is the levelized cost of energy. Now this is for new builds. This is not for existing plants. The reason why I looked at new builds is because that's where the data is currently available and it's most consistent. So I tried to keep that as consistent of a measure as possible. Morgan.
So we're trying to create an economy here in Western in Colorado and really
Yes.
figure it out. Can you guide us a little bit on what types of information would be helpful for you to create a better model? What do you need?
That's a great question. So if everybody heard Morgan's question, Morgan's asking, okay, so what information do I as an economist need to create a model? Right now I'm working with well, I will be working with Calvin, and I'm also working with another agronomy professor at CSU by the name of Jerry Johnson. He is focused on oilseed production. He's also working with, in Rocky Ford, the production there. And I have a graduate student who's actually modeling how can this be done in a profitable way. So we're specifically looking at the crop camelina. Now the nice thing with camelina is that it could be grown when the field would otherwise be fallow. So in other words, you know, if you're growing camelina and there wouldn't otherwise be anything, if you can fit it in there and still grow wheat, that potentially would be a good revenue builder. Now, okay, so what we would need, the information that we're looking at is, how much are you spending on insecticides for the camelina? How much are you spending on the diesel? So when we get those operational cost information, what we can do is build, you know, you've seen the bell curve, you've talked, you know, about the bell curve. What is going to be potentially the high cost of diesel? What's the low cost of diesel? If we know how much you have to spend to put in the camelina, we can create a distribution function and tell you, okay, here's your worst case scenario, here's your best case scenario, here's your typical scenario. So to answer your question, what do we need? It would be great to have your cost information. And we don't have to identify you. We don't have to say this is, you know, this is, you know, Ms. Rancher Jones from, you know, Fruta. Just having that cost information helps us create a model, and that we can provide that information to you. So thank you.
Thank you, Catherine.